Blessed day to all. Welcome to my channel, Math with Mrs. O. I'm Ofelia Orate, a principal owner of a school and a tutorial center, a math teacher, and an author of 21 books. Before we start with our lesson on rational equations, please smash the subscribe button and hit the bell button. Thank you. Okay, so today we're going to study how to find the solutions or the solution set. What is the difference between the solution and the solution set? When you say solutions, you're solving for the x value. When you say solution set, the set of all the solutions. So that's the main difference. So solutions and domain of rational equations. So we have different examples here of different types, and as you go on, you will see that the difficulty is going up. So problem number 1, you're supposed to find the domain and the solution set. Okay, in problem number 1, 5 over x equals 0. Let's identify the domain first. The domain, let us recall, I have already defined this in my previous video, but let me define it again. The domain is the set of all possible or permissible values of x, or the possible values of x that will not make it undefined. In short, the set of all possible values of x or any of your variable. So the domain here, as you can see, can be any real number except 0. Why can't 0 be a value here? Because if you observe, if 5 is divided by 0, it becomes undefined. Therefore, x cannot be 0. Now, what about the solution set? SS or solution set, or the set of all solutions. You will observe that when x equals 1, 5 over 1 is equal to 5 and not 0. 5 over 2 is equal to 5 halves or 2 and a half, and it is not 0. You let x be 3, 5 over 3 is 5/3. It is not 0. So therefore, if you go on and substitute any value for x, what happens? It will not be equal to 0. So here, there is no value of x that will make it true. So the solution set is nothing, empty set, meaning no value of x. Now, let's proceed to problem number 2. In problem number 2, we start with the domain. The domain, the set of all possible values of x. Take a look at the denominator. The denominator should not be 0, isn't it? Because if the denominator is 0, 5 over 0 is undefined. So x minus 2 cannot be 0, and then you solve for x. X cannot be 2. So your domain is x is an element of real number. X cannot be 2. What about the solution set? For the solution set, there are actually 2 ways. One way is for you to multiply the LCD. So, the denominator of 5 is x minus 2. It is understood that the denominator of 3 is 1. The LCD is x minus 2. Let's multiply x minus 2 to the left and to the right. There. This is not raised to x minus 2. I'm multiplying x minus 2 to both sides. What is that property that allows us to multiply x minus 2 to both sides? That is the MPE, the multiplication property of equality. So if we multiply x minus 2 to both sides, x minus 2 times the quantity 5 all over x minus 2, the x minus 2 cancels. So we are left with 5 is equal to 3 times x minus 2. So we have here 3 times x is 3x minus 3 times negative 2 is negative 6. And then there, you can now isolate x to one side, transpose positive 6. So this is 3x and transpose that. This is 11 equals 3x. To isolate x, divide both sides by 3. You can cancel this. So therefore x is equal to 11 over 3. Or what is 11 over 3? What's that? 3 times 3 is 9 and 2/3. Let's check again. 3 times 3 is 9. 9 plus 2 is 11 over 3. So there. So therefore, our solution set here is x is equal to 3 and 2/3. There. You know, sometimes your teacher would require you to write it in such a way that such that x is an element of R. X is equal to 3 and 2/3. That's all right. You follow your teacher. It's the same thing. Here we are assuming that x is any real number, is under the set of any real number. Here you're specifying that x, or the replacement set, is the set of real number such that x is equal to 3 and 2/3. It's the same thing. You follow what your teacher requires you to do. If he wants this, give him this. Wants this, give him this. So, you can also do it this way. Let us say you don't like it this way. You can also do it this way. 5 all over x minus 2 is equal to 3. 3 is 3 over 1. You can transpose 3 to the other side. 5 all over x minus 2 minus 3 over 1 is equal to 0. Now, make the denominators the same. X minus 2 divided by x minus 2 is 1 times 5 is 5. Minus x minus 2 divided by 1 is x minus 2 times the numerator 3. There. Let me repeat that. X minus 2 divided by 1 is x minus 2 times 3. There. And then simplify this. So 5 minus 3x plus 6 all over x minus 2 is equal to 0. And then from here, we simplify. 5 plus 6 is 11 minus 3x all over x minus 2 equals 0. So if a over b equals 0, then a has to be 0. So the numerator 11 minus 3x is 0. Transpose 3x to the other side. So now divide both sides by 3 and making it fast. X is equal to 11 over 3 or 3 and 2/3. There. Then you see that this is the same answer as this one. Then you write your answer as this one. So you can now choose whether you do it this way or this way. You'll get the same answer after all. Let's move to problem number 3. In problem number 3, I made sure that you have a monomial in the denominator. You will see why. So, if you have a monomial in the denominator, it would be better if you apply the MPE by multiplying a to both sides of the equation by MPE. Oh, and then solve for a. You see that this cancels with this, so you're left with 5 minus 2a is equal to negative 3a. Combine all the a's on one side, so we have here 5 is equal to negative 3a plus 2a. So 5 is equal to negative 1a or negative a. So 5 is equal to negative a, so therefore a equals negative 5. So in your solution set, you can just write a is equal to negative 5. What about the domain? For the domain, it's easy. What are the possible values of your variable a? Any will do, except, yes, except 0. So you can write here x is an element of R. X, not x, this time it's a. So it's a, it's an element of R. A is not equal to 0. Let's move to problem number 4. As you can see, I made it a little bit more difficult. In the previous examples, the denominators are just very simple. This time, as you can see, the denominator is a difference of 2 squares. So you can factor it as 3 plus 2b times 3 minus 2b. Difference of 2 squares. And this is now 2b plus 1 times 2b minus 1. We need these factors for us to determine the domain. Okay, what is the domain now? So for the domain, we have x is an element of R. X cannot be 3 plus 2b cannot be 0, isn't it? So 2b cannot be negative 3. Divide both sides by 2. B cannot be negative 3 halves. That is 1. So this should not be x, this is b. There. You follow your variable. So b cannot be negative 3 halves. So here, it's the same thing. 3 minus 2b cannot be 0. So negative 2b cannot be negative 3. Divide both sides by negative 2. B cannot be positive 3 halves. So we can just write here, B cannot be plus or minus 3 halves. B is not plus or minus 3 halves. What else? Here, 2b plus 1 cannot be 0. So 2b cannot be negative 1. Divide by 2, b cannot be negative 1 half. So I'll make it fast here. So 2b minus 1 cannot be 0. 2b is not 1. Divide by 2, b is not 1 half. So in other words, b cannot be plus or minus 1 half. There. So you need to factor the denominators in order for you to identify the domain. Now, to solve for the solution set, I'm going to use another method which is different from the ones we use in examples 1, 2, 3. You can now cross multiply them because it will be easier. Let's call this my aura technique. So you cross multiply this and this. There, it will give you 1 times 4b squared minus 1 is 4b squared minus 1. Also, multiply this and this. So you have here 4 times the quantity, 9 minus 4b squared. There, again, you cross multiply, we have this. Cross multiply, we have this. Now let me erase this one, it might distract you. There. Then simplify. So we have 4b squared minus 1 equals 9 times 4 is 36 minus 16b squared. Combine like terms. So transpose negative 16b squared to the other side. You will be getting 16b squared equals 36. Transpose negative 1, that is positive 1. Add this, you get 20b squared equals 37. Then you divide both sides by 20. There. So we are left with b squared equals 37 over 20. Then take the square root of both sides. We have here b is plus or minus the square root of 37 over the square root of 20. Take note that the square root of 20 is just the square root of 4 times 5, which is square root of 4 is 2 times the square root of 5. There. So we have here square root of 37 over 2 square root of 5. But wait, there's more. There's a square root of 5 in the denominator, so this is not yet simplified. We have to rationalize it by multiplying square root of 5 over square root of 5. So this is now plus or minus square root of 37 times 5. 37 times 5, so 7 times 5, 35, carry 3. 5 times 3, 15 plus 3, 18 over square root of 5 times square root of 5 is 5. 5 times 2 is 10. There, you have the solution set. Square root, because this is square root, so you have square root of 185 over 10. Now the question is, can we still simplify this? If you have 35, 37 and 5? No, not anymore. So this is now your final answer. So if you want the solution set, you just have to put parentheses here, okay, for your solution set. Now let's move on to problem number 5. As you can see, you have a trinomial in the denominator. So there's a need for you to factor it again if it is factorable. Let's try. Are there factors of negative 6 which when added will give you negative 1? Factors of negative 6 which when added will give you a negative 1. So we have negative 3 times 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. The middle term is negative 1. Remember your factoring. So we have here x minus 3 and x plus 2 because it is a simple quadratic trinomial. Here, it's a little bit complicated, so we do it this way. 3 times negative 2 is negative 6. Factors of negative 6 which when added will give us a 5. So we have positive 6 times negative 1. Repeat, positive 6 times negative 1 is negative 6. Positive 6 plus negative 1 is positive 5, the middle term. Okay, this negative 1 is the middle term here. You can write this as negative 1x there. Oh, and then, what did we learn here? We can now rewrite this as 3x squared plus, this one becomes 6x plus negative 1x. This is now negative 1x. Rewriting 5x. Your factoring technique which you learned when you were in grade 7. And then you group the first two and the last two. Factor out what is common. 3x times the quantity x plus 3x squared divided by 3x is x. 6x divided by 3x is 2 plus common factor out negative 1 times the quantity x plus 2. There is a common factor. So your factors are now x plus 2 and 3x minus 1. These are the factors of your denominator here, and these are the factors of your denominator on the other side. Now, we can now find the domain. So what is the domain or the set of all possible values of your variable x? Take a look at this. What will make this 0? Yes. X minus 3 cannot be 0, so it cannot be 3. X is an element of R. X is not equal to 3. Here, negative 2, it cannot be negative 2. When x is negative 2, negative 2 plus 2 is 0. So the denominator becomes 0. 2 divided by 0 is undefined. What about here? Here, x cannot be negative 2 also, so you don't have to write it here. What about this one? 3x minus 1 cannot be 0. Otherwise, everything becomes undefined. So 3x cannot be 1. Divide by 3. Then x cannot be 1/3. There. Okay, so your domain cannot be 3 from here, negative 2, and 1/3. So you really have to do factoring before you can determine the domain. Now, let's move on to solving for the solution set. The easiest way, the fastest way, cross-multiply this, or a technique. Okay? So we have here, you cross-multiply. So we have 2 times the quantity, 3x squared plus 5x minus 2 equals, also multiply this 2, we have here 3 times the quantity, x squared minus x minus 6. Simplify. So this is 6x squared plus, this is 10x minus 2 times negative 2 is negative 4 equals 3x squared minus 3x minus 18. Now, combine like terms. Transpose this to the other side. It becomes negative 3x squared. We combine this. Transpose negative 3x becomes positive 3x. Transpose negative 18 becomes positive 18. You transpose all of this, so this becomes 0. And then let's add them because you have transposed them to the other side. So 6 minus 3 is 3x squared plus 13x plus 14 equals 0. There. Let us now solve a quadratic equation. What did you learn? You can solve a quadratic equation by factoring by completing the square and by the quadratic formula. Let's try factoring. 3 times 14. 3 times 14 is 4 times 3, 12, carry 1. 3 times 1, 3 plus 1, 42. Now, give me factors of 42, which when added will give us 13. 7 and 6, right? Both are positive. When you add them, you get a 13. Factors of this, 42 again, so that when you add them, you get the middle term, which is 13. This one. I repeated so that you will understand more. There. Then, copy 3x squared. Rewrite this as 7x plus 6x. And then copy 14. Plus 14 equals 0. Combine this 2. So we'll have here, factor out the common factor. We get x times the quantity, 3x plus 7. Plus, what is the GCF here, the common factor? 2 times the quantity, 3x plus 7 equals 0. Now, you see this? Mabuhay. So we have a common factor. Factor it out again. So finally, we have 3x plus 7 times x plus 2 equals 0. So here, 3x plus 7 equals 0. 3x equals negative 7. Divide both sides by 3. X is negative 7 over 3. What about here? X plus 2 equals 0, so x is equal to negative 2. Now, let's check the domain. Look at the domain. X can be any element of the real number, but x cannot be negative 2. X cannot be negative 2. Therefore, what does that mean? It means that this is an extraneous solution. This is an extraneous solution. So you don't include it in the solution set. Therefore, in our solution set, we will only take or have negative 7 over 3. Extraneous solution is an extra, from the word extra, root word extra. It is an extra solution that you are able to get here, but since the domain doesn't allow it to be in the SS, you cancel it. So in the SS, this is cancelled, and you will only have negative 7 over 3 as your final solution. Oh, I'm so happy I was of help to you. Please don't forget to add kindness, subtract judgment, multiply understanding equals Mrs. O's good life equation. Smash the subscribe button now and hit the bell button. Bye. Thank you.